Hello guys, if you are in grade 12 or you have a child that's in grade 12 or you are writing your supplementary exam, listen to this video until the very end. Well, if you want to request for a one-on-one session, WhatsApp me on these numbers. And also if you want to join our exam focus program that's going to help you prepare for your June examination, your trial examination, as well as your final examination, ensure that you WhatsApp me on these numbers. The program is actually starting on Monday. Ensure that you join. We are starting. Make sure that you want to start with us. Ensure that you join. I'm going to emphasize this. Ensure that you join. Otherwise, guys, to join the program, you are going to use the link on my bio. So ensure that you are using the original TikTok, not TikTok Lite. And then you got to make your payments there. And then I'm going to see you on Monday. Well, for today, let's actually answer this question. This question is actually on calculus. So it is one of those questions that a lot of people find difficulties on. And I just want to wash that mindset away as we actually try to answer this question. Let's actually look at it. The first question, I'm actually looking at my pen. Okay. The first question said they want us to find the coordinates of C, right? What is the coordinates of C? If you check the coordinates of C, it is the x-intercept of the cubic function, and it's also the x-intercept of the straight line. But the equation of the straight line, it is actually g at x minus x plus 2. So it means that if we put 0 here, we end up having 2. So it actually shows us that the coordinates of C, it is just 0. It is just 2 and 0, right? Now, the second question says we need to show that the value of A is minus 1 and the value of C is 3. So they're actually talking about these values from this expression. Let me just change my pen. So the cubic function is actually given by f at x. That actually equals to ax cubed plus cx plus 2. So they want us to show that a is minus 1 and c, it is actually 3. So how do we do that? Well, you're going to use this equation that say y equals to ax minus x1. In this point, we need to cube this first bracket. Why do you cube it? Because if you check, we are actually having x-intercept and a turning point at this point. So minus 1, it is the x-intercept of the cubic function, and minus 1, it is actually the x-intercept of the cubic function. So we need to square it. And then we're also going to have x minus x2. We're having a point, and this point is actually at 2. When y is 2, our x is actually 0. And the x-intercept and the turning point that we have, it is actually minus 1. So because of this minus, it will change into 1 squared. Remember, when y is 2, our x is going to be 0, and the other x-intercept is going to be 2. So it's going to be minus 2. So this is going to be, oh, this is squared, by the way. This is going to be 2. That actually equals to minus 2a. Because this is just going to be 1, and then you're going to say a times minus 2 is just going to give you minus 2a. So if you divide both sides by minus 2, you find that indeed your a actually equals to 1. So what you are required to prove, you have actually proved it. We have actually found that a indeed actually equals to 1. But how do we actually find that the value of c actually equals to 3? Well, if you check closely, you can use this point or this point to prove, but you cannot use this point. Why can't you use this point? You cannot use this point because the x is actually 0. So if you put 0 in here, you are left with nothing. So you can choose this point or this point. Let me just choose this point. We know that when x is minus 1, the y is going to be 0. So I'm just going to put 0 in here. And then the value of a is minus 1. And x is actually minus 1. I'm going to put a cubed in here. Plus, I'm trying to find the value of c, but my x is minus 1. And then I'm just going to add this positive 2. So what are we going to have? We're going to have 0 that actually equals to minus 1 cubed is going to be a minus answer, so we just turn into 1. Minus, right? Let's actually look at this. If we actually put minus 1 here, we're going to have minus c plus 2. So 1 plus 2 is going to give us 3. So if we take this 3 to the other side, we're going to have minus 3 that actually equals to minus c. So if we divide both sides by minus 1, we find that the c actually equals to 3. And it is exactly what they wanted us to prove, right? Now, let me just turn this paper upside down. They now say we need to find the turning points at B. What is the turning points at B? The turning point at B, it is actually the first derivative. What do we know about the first derivative? We know that the gradient at the turning point is actually going to equals to 0. We know that. We know that the gradient within the turning point is actually going to equals to 0. To those of you who haven't yet done calculus, f at x means y-intercept, as you always knew it. But when we talk about f prime of x, we are talking about the gradient. And within the turning point, the gradient is actually 0. I'm not going to talk about y at this video because that's just a topic for another day. But how do we move from f at x to f prime of x? What is our f at x at this point? If you check our f at x, it is going to be a that equals to minus x cubed, c that equals to 3x plus 2. If you want to move from f at x to f prime of x, you actually say 3 times minus 1 is going to be minus 3x. And then on this 3, you're going to minus 1. It becomes a squared. And then the other thing that you want to do, you know this is the power 1. You're going to say 1 times 3. That's just going to be 3. Minus 1 is going to be x to the power 0. And anything raised to the power 0 is just 1. And then this is actually x to the power 0. So it's just going to be 0. Now, we have said that the gradient in the turning point is 0. So we're actually going to write 0 where this f prime of x. And then we'll be left with minus 3x squared plus 3. Well, we can actually take the common factor of 3 and we'll be left with x squared minus 1. So it means that we know we're going to have x squared that actually equals to 1. Therefore, we're going to have x that actually equals to plus or minus 1. So it means that the x turning point, it means that our x turning point, it is actually at minus 1, and it means that at B, it is going to be 1. But how do we find the value of y? To find the value of y, we are going to substitute positive 1 on this original expression. It's going to be minus 1 cubed plus 3, 1 plus 2. That actually gives us 4. So it means that the coordinates of B is 1 and 4. So that's what we're going to write. We're going to say, well, B it's 1 and 4, right? Now, let me just change this paper. Let's look at the next question. The next question says, find the x coordinates of the point of inflection. How do we find the coordinates of the point of inflection? Well, to find the x coordinates of the point of inflection, you need to derive for the second time. So this is the first derivative. So what is the second derivative going to be? If we derive for the second times in terms of x, we're just going to get minus 6x, because it's going to be 2 times 3 is going to be minus 6. 2 minus 1 is just going to be x. But we know that the value of the second derivative at the point of inflection is going to be 0. So we're going to have 0 that actually equals to minus 6x. Therefore, the value of x within the point of inflection is indeed going to be 0. Now, let's look at this next question. This is the question that I love so much. This question says, find the values of k where f at x equals to k will only have one root. They don't care whether it's positive or negative. They're just saying that find the values of k where f at x equals to k will only have one root. So I want to show you how you find this kind of questions. Well, let me use this ruler. We're gonna use this ruler. You see where this ruler is at this point, we are on a point where this ruler is actually touching three roots. The first root is this one, the second root is this one, and the third root is this one. So they want us to find a point where the ruler will only be touching one root. If we move upwards to this turning point, we find that the ruler is still touching three roots. It is 1 point here. Oh, it's touching two roots because it's 1 point here and it's actually 1 point here. But what happens if we take the ruler upwards? If we take the ruler upwards, you realize that the ruler is now touching only one root. Do you understand this? It is no longer touching two roots. It is only touching one root. So we see that from the turning point upwards, the ruler is touching one root. So how do we write this? We're going to say, well, the first value that we find, it is k greater than 4. Because we're actually looking in terms of y, not in terms of x. We're looking in terms of y. So as you can see, when y it is actually equals to 4, we are going to touch only one root. But from 4 upwards, do you understand this? From 4 upwards, we are only going to touch one root. But there's another answer. It is actually on the lower turning point. If you check our ruler at this point, it is touching this root and also this root. But if we move downwards, it is only touching this root. So this is when k equals to 0. So therefore, another answer, it is when k is less than 0. So how do we write this? So we say, therefore, it is k greater than 4. Let's just say something like this. I think it's k greater than 4, less than 0. Right? Now let's look at this other question. This other question says, write down the values of x for which f prime of x is less than 0. What is f at x? This is the y-intercept. What if f prime of x? This is the gradient. Whenever they say f prime of x less than 0, they are telling us when the gradient is a negative. And when the gradient is a negative, it is when the graph is what? Is decreasing. Where on this diagram is our function decreasing? If you can look at this, from negative infinity until where x actually equals to -1, the graph is decreasing. The graph is decreasing. So our first answer, it is x less than -1. So from negative infinity until -1, the graph is actually decreasing. But from x minus 1 to x equals to 1, the graph is increasing. We don't look at that. We don't want that. We only want when the graph is decreasing. But as you can see, from x equals to 1 to positive infinity, the graph is decreasing again. So the second answer, it is x greater than 1. So ladies and gentlemen, that is how you were supposed to answer that question.